This conference will now be recorded.
Okay, so file IO, that's input and output. Okay, so let's see what an input or output is. Okay, so this is your application. Okay, as in your program. Okay, this is your app or program. Now, any information that flows towards your program, okay, that's an input. Okay, if your program is receiving information from outside source, we call it as input. Okay, it's also called reading. Okay, if your program is sending output, okay, if your program is sending output outside, sending information outside, that's called as output. Okay, and from your program point of view, it is called writing. Okay, when you're reading information, the information flows towards you. When you're writing information, the information flows towards other source. Okay, does that make sense?
Yes.
Read and write, input and output. Okay, now this program could be reading or writing, receiving input or sending output from different sources and different kind of information. Okay, so when you're writing information, the first question you ask is, what is the type of information? Okay, what information are you writing? Okay, what information are you sending out, and what information you are receiving? Okay, what information you receive and what information you send. Okay, now broadly speaking, information can be split in two categories. One is a text info and another is binary info. Okay, text info or binary info. Okay, that's your information type. Now, text, or we can call it characters. Now explain some, give me an example where you receive a text information or a characters. You have several applications, right? You have mobile app, desktop app. You have a lot of applications running on your cell phones, your application, your desktop, your PC, your laptop. Anytime you receive a text information, we categorize them as character string. Okay, so do you guys want to give an example?
Text message.
Text message, yes. Okay, when you receive a text message, that is basically a text information coming to you. Okay, basically you can open that information and read it. Okay, it's a readable information. Okay, text information or any post, any chat application. Okay, all these things are character strings. Okay, now give me an example of binary strings. Any information that doesn't come in the form of text, readable text. Anything that is not readable, not in a text file format, they are all binary string. They are all binary. So, any examples?
A picture or something?
Images, yes. And Okay, it shouldn't be that hard. You guys are using this cell phones and PCs for quite some time. Can you name anything that is not a text?
Phone call.
Phone call. Okay, when you make a phone call, you listen to audio from the other side. Whoever is speaking on the other side, you can listen them. So that information is again an audio file, okay, which is not a character string. That's a binary. Yes. Images, it's a binary. Video, when you go to YouTube, Netflix, you download something, you upload something, all that information is coming to you, all that video and audio. They are all binary. That cannot be opened in a text file, text editor. Okay. Okay. The action that we perform in this operation is writing. Okay. When you write something in the program, it goes outside. Okay. Second, what is the category of this information? When these systems, okay, whatever, this could be anything, input and output, this could be anyone or anything. When these systems or these programs send information towards you or you write information outwards, that information can fall in two major categories. You might be writing a text information or you might be receiving a text information. That's what the character stream means. Okay, stream is like a continuous flow of data. Okay, stream in the sense like a water flow, water flow. Okay, that's what you have to think of when you hear the term stream. Okay, so the information is flowing towards you, which is a text information. Information is flowing outward, that is a text information, character streams. Okay, similarly, the binary stream is something when a program or other person sends you information which is not textual. Anything that is non-textual, it's all binary. Okay, if you receive an image, have you ever tried opening a file in a text editor, an image file? You won't read anything. Have you ever tried to open a movie, a video file, or an audio file? You can't read anything. Okay, so all those files comes in this format, binary stream. Okay, so we have character stream and binary stream. Now,
This conference will now be recorded.
okay, now let's see what are the different sources. Okay, now you might be reading information from other sources, okay, like your hard drive. Okay, so what kind of information do you have in your hard drive? Okay, what kind of information do you store on your hard drive?
Everything.
Okay, you have text files, you have audio, you have video, right? You have all sort of files there. So when you are launching a software that is playing a video, that video player software, what is it doing? Is it reading or writing?
Reading.
It's reading, right? So on your hard drive, you have a video MP4 file. Okay? So you have a MP4 file, and let's assume this application, this program is a video player program. So when this program is playing your video, it's basically taking the input from your hard drive, okay, which is located in this path. Okay, you have stored this movie, this video file somewhere on C drive, videos. Okay, you have a movie that is stored in C drive, videos, movie, MP4. So your program is basically receiving input from this location. Okay, now if your program is creating a text, okay, it's creating a file that is storing in the hard drive, that would be more like an output. Okay, if you want to create a file in this location, my notes june25.txt. Okay, so this is a text file. If your program is making notes, okay, and storing it in the hard drive, that would be more like a write action. Okay, so now you're writing some text content into this file. So in case of this action, tell me exactly what action it is and which stream it is. Okay, you have to use the both the combination. Something like it's a read character stream, it's a write binary stream. Okay, so tell me, if you want to write, or if you want to create a text file in your hard drive, what's the combination that you need?
Write character stream.
You need a write character stream. Okay, you want to write or create a file with some content that is text or character. Okay, now when you're playing a video on your drive, what is that streaming combination?
Read binary.
Read binary stream. Very good. Okay, now YouTube, you're playing a video on YouTube. What is that? What stream is it?
Read binary.
Yes, it's a read binary. But here is the question. When you're watching a video on YouTube, it's definitely not coming from your hard drive, isn't it?
Yes.
So where is that coming from?
From the website of YouTube.
Yes, it's coming from the YouTube's machine. Your machine is downloading something from YouTube's machine. But here is the thing, it is still a read binary action. Okay, YouTube is still a read binary action. Okay, you're basically reading something that is flowing towards you from YouTube servers. Okay, so YouTube software is definitely not running on your machine. It is running somewhere on Google's headquarters. Okay, so Google's headquarters has some YouTube server, YouTube machine, which has all the videos. So when you say read and write, it doesn't have to be always the hard drive. You might be reading or writing information from a lot of different sources. Your hard drive, or maybe your friend's system, or maybe from Google's machine, or maybe from Facebook's machine. Okay, so when you send out an email, now tell me the combination of what action, what stream, and what is the endpoint. Okay, something like this requires a write character stream on my hard drive. Okay, so this action requires you need to write using character stream on my hard drive. Okay, this is what you need to do to create this file on your hard drive. Now my question is, when you create an email, okay, you are creating an email on the browser, what action is that? When you create an email, what action would that be?
Character stream.
It's a character stream. Okay, okay, remember, I want a comment
Write
like
character stream.
write
Character stream.
character stream. And what's the destination? Is it going to your hard drive when you send email?
No, it's not going to the hard drive.
So let's assume this is Gmail that I'm talking about. So where does that information go? What's the end point?
Character stream. Gmail.
The server.
This Gmail's machine, right? It goes to the Gmail machine. So basically you're using a write binary stream, and where that information ends is the Gmail machine, wherever it is. Okay, that's an action involved in email. So this GoToMeeting, what is this GoToMeeting doing right now? GoToMeeting app. Think about it carefully. What would be the GoToMeeting's action with respect to input and output?
It's reading binary stream.
It's reading binary stream. Very good. Is it just reading or writing as well?
For you, it's writing. For us, it's reading.
Yes, it's both. Now, when I'm talking, when I'm sharing my screen, all my information is going towards GoToMeeting's machine. Okay. At the same time, whatever you guys are talking, whatever chats you are typing, all that message is also coming towards me. I can hear your voice, right? So for me, when I'm sharing my screen, it's both. I'm basically writing binary stream, okay, because my screen is being shared, and that information is traveling all over the internet towards the GoToMeeting and then to you guys, because you can see my screen. So that information is flowing from my desktop to you. So I'm writing binary stream. At the same time, I can hear you guys. So that information is also flowing towards my machine. So GoToMeeting is more like both. It's a read and write binary stream. Does that make sense?
Yes, sir.
Now, with that point, what would you categorize download and upload as? Which is input, which is output, which is read, which is write? Download and upload.
Download is read,
Very good.
upload is write.
Upload is write. Okay, when you download something, information comes to you, you download on your machine. So that is more like a reading. It's an input to your machine. Someone is sending something, you're downloading that. So information comes here and it downloads on your machine. When you're uploading something, basically you're writing something. It goes as an output from your machine to the outside world. Okay, so that's how you need to understand. Read, write. Input is similar to download. Output is similar to upload. So if you really think about it, the entire internet is based on input output, isn't it?
Yes.
Everything is download or upload. Every time you send an email, you send a like, you post a message, you upload an image, or you watch other people's blog, other people's post, it's all the time being downloading or uploading certain things. Okay, you are using input output. You have been around this input output concept from day one, since you guys have been using internet. Okay, so that's as easy as you can understand. Input output, read write. Okay, all right, so you guys get the concept of what input output is and how you categorize them under read write and everything.
Yes.
Okay, all right, so now let's write a program. Okay, how do you actually read or write a character data and a binary data? Okay, now since we cannot actually write a program that can send something to YouTube or Facebook, right? We will be writing an example with only one endpoint, which is hard drive. Okay, technically download and upload requires an outside system like a YouTube or Gmail, where you send something to the outside system, okay, or you receive something from outside system. Okay, so that requires you to write and read from outside the hard drive, okay, on the internet. Okay, since we don't have that capability, the concept is still same. You still have to do read and write using character or binary string. That doesn't change. So for the sake of our example, what we'll do is we'll read and write from our own hard drive. Okay, you either read and write character and binary stream to your own hard drive or to an outside machine like a Gmail, or read it from YouTube. Read it from YouTube or send an email to Gmail output. Okay, so the concept is still same. This part will not change. Reading and writing character and binary stream, this part will not change no matter where the end result is. Is it ending, does the data end up on your hard drive or on the Gmail machine? This information or the program that we write the code now will always remain the same. Okay, okay, so there are several different categories: input stream and output stream. Okay, now every time you find some program, again, these all programs are inbuilt in the JDK library. Okay, you don't have to write anything. These are already there. You just pick it up and start using. Okay, now the inbuilt Java programs that we have fall in two categories, as you already know. Okay, they fall in two categories: character stream and byte stream. Okay, or binary stream. Okay, this is the code to write binary. And this is the code for writing, reading and writing character strings. Now, if you look at this carefully, the names will make a lot of sense. Okay, every time a class name ends with a reader or writer, you're basically referring to character streams. Character streams are the ones you read or write. Okay, that's, I mean, you can actually understand the content when it comes to text files, character files. Okay, so any class name that ends with reader or writer, they are basically referring to character strings. Any class name that ends with the name string, okay, anytime your program ends with the name stream, input stream, output stream, buffered input stream, buffered output stream. Okay, anytime the name ends with a stream, you are basically performing some binary activity. Okay, you're reading or writing binary information. Okay, so let's start with some simple things. If you want to create a file, there is an inbuilt Java program, java.io.file. Okay, so this is an inbuilt Java program. What you do is you create the file object, and you pass the path. Okay, so this path is basically pointing to your hard drive. Okay, so we are saying I want to create a file object in this location, D drive, and the file name is test.txt. In the D drive. Okay, let me delete this. Okay, so right now we don't have any file called test.txt. Okay, in the D drive we don't have any file called text.txt. Okay, so let's create a file with that name. First, initialize the file object. Okay, the constructor of the file object takes the location of the file. Okay, so if you want to deal with some location, like you want to create a file in certain folder, you have to give that location here. Now, if you notice, I have given two slashes, // okay, so if you don't want to give two slash, you can do this backward slash. Okay, now the reason we do this is, do you guys know how to create a new line in sysout?
/n.
/n, right? Now /n meaning new line. Okay, this is a special, this slash when you use in a string double quote, this has a special meaning. When I sysout /n, it is not actually printing /n, and whenever you give slash, it means the next character has a special meaning. N stands for new line. Okay, so when you write /n, what you get output on the console is a new line, new blank line. Okay, similarly /t has a special meaning as well, which is
Tab, like space, a long space.
okay, so whenever you press a tab key on your keyboard, it will go with one big white space. Okay, that's what tab does, right? So /t meaning tab. Okay, now when I'm giving the path like this, wouldn't this be a mistake? because string will consider the /t as a tab and not as a path, isn't it? /t will be considered as a path, as a tab. Okay, but what we really meant is this thing. Now, if you notice, whenever you open a folder path like this, here, this is how the path looks like. In the D drive /tutorial/bk. Okay, this is the path where you'll find Java and J2E spreadsheets. So this is how technically Microsoft Windows displays the file path. Okay, but Java has its own understanding of a /t. Java has its own meaning for /t. So how do we escape that? We put another slash in front of it. So you put 2 slashes. Now what you're trying to tell Java program is, I don't mean the tab. I'm actually trying to say that I want to create a file in D drive /test.txt. So this is what we call escape sequence. Escape sequence will override whatever the true meaning of the /t is. Okay, but if you don't want to go into that mess, you can just do the backward slash. Okay, rather than forward slash. Okay, you can do this, or if you're using this slash, you have to use it twice. Okay, all right, now let's create this file. Now when you initialize the file object, the file class has certain methods. Okay, the file class has certain methods like create new file, delete, okay, is directory. There are so many programs, so many methods that are available. You can delete is directory. You can check if the location that you gave here, is it a directory or is it a file? Directory as in folder. So is the location that you mentioned here, is that a folder or is it a file? You can write that here. Okay, now let's start with the first one. I initialize the file object with a path. Okay, with a path, and then I will call the method create new file. Okay, so when I execute this, you will notice D drive test.txt. In the D drive, I don't have any test.txt file yet. Okay. All right, so let's write this now. Okay, program successfully done. And you have a file called test.txt. So you created a file in the D drive with the name test.txt. Okay, so this is how you can create a file. Now, if you want to delete that file, you can just say dot delete method. When you call the delete method, this file will be deleted. Okay. Okay, so that file is deleted now. Okay. Now, let's try to write some content in that file. Okay. So this is a text file. I want to write some content. Okay. I want to write some characters. Okay. What is the best? What is the stream combination you need? Character or binary? Read or write?
Right.
You need a write. And which stream do you need?
Character.
Character stream. Okay. So character stream code is usually like this: reader, okay, or writer. Okay. So we can use this. Okay, so let's see. Now you're already aware about what the first two lines do. Okay, the file class basically only deals with creating files, deleting files, okay, or checking what is the type of the file. Is it a text file? Is it a directory? What are the sub files under the folder? Okay, the file class is basically dealing with only creation and deletion and reading. Okay, so you can check what is the file under this folder. You can check that using the file object. Okay, you can create a file, you can delete a file, or okay, so you can do all those basic activities. You cannot play with the content. Okay, you cannot write anything or read content, read anything. For reading and writing, you have other programs like a file writer or a file reader. Okay, so first we initialize the file object and call the method create new file, which will create the file in that location. Okay, once you have created the file, the next step is to write something in that file. Okay, for that we have another program called file writer. Okay, so file writer, you can name anything you want for the variable new file writer. So do you notice what is the input for the constructor file writer? What parameter does the file writer constructor receive?
Write-up.
And what is the data type of write-up?
File.
So file. So this is a constructor, okay, that takes file as an object. Okay, this is a constructor that takes file as an object. So when we created the file object here, we passed the same object to the file writer constructor. Okay, now coming to the file writer class, there is a method called write. Okay, now when you say write, you can pass a string, a character, bunch of characters. So what it will do is it will basically give you this content in the file location d drive test.txt. Okay, let's see how this will work. Okay, the file is created. Okay, the file was created in the first two steps, and using the file writer program, we were able to write this content from our program. This information is flowing outwards. We are writing information towards the hard drive. So open this file, and you have that string that you wrote from the program. Okay, you can delete this and try something else. Okay, the file is again created, writing characters to the hard drive text file. Okay, so that is the content that our Java program wrote on your hard drive. Okay, all right, so does everyone understand how to create a file and how to write contents, text content to a file?
Yes.
Yes, sir.
Now there is one more twist here. You'll always hear the term buffer. Okay, buffered is a very quite common term. It's the same process. Okay, it's the same conclusion. Okay, it will write the contents to your file anyway. Okay, it will still write some content to your file. Okay, so let's understand the term buffer. Okay, it's the same thing. Okay, we are still able to write contents, maybe using the file writer object or the buffer writer. In either case, we still wrote this string in a text file on your hard drive. But let's explore what buffered means. Now, where do you hear the term buffer when you're on the internet?
Streaming.
Streaming. Okay, what basically happens when you hear the term buffer?
Downloads, I guess.
Okay, so this is what happens. Now, every time you watch a video, you might see this experience. Okay, go to YouTube and just play any video. There are two bars. Okay, there are two progress bars when it comes to a video. Okay, there are two progress bars. Okay, okay, there is one gray progress bar, and there is another one which is red. Okay, there is one gray bar going through, and then there is another red bar. Buffer the video up to a certain point. So even if the internet becomes slower for the next 5 seconds, will your video stop?
No.
If your internet connection drops for 5 seconds, how does that improve performance? Let's see. Okay, so this is your Java program, and you are writing this text to your hard drive, which is in this location. So you're writing this text in this hard drive file. Okay, there are two ways you can achieve this. Okay, so when you're writing a program, okay, so you're sending data to this location. Okay, D drive test.text. Okay, now when your program is writing data from here to here, there are two ways. Either you can make several trips between the program and the hard drive file. Okay, you can make several trips, like write the W character first, and then write the R character, write the I character, T, I, N, G, space, D, A, T, A. Now tell me one thing. when you guys are relocating to a new house, a new apartment, how do you move all your things from your old location to the new location? Do you carry one spoon at a time from your old location to the new one, or do you buffer everything in your trunk and go at once? How do you do that?
Go at once.
Go at once. Isn't that more efficient than making 100 trips between location 1 and location 2?
Yes.
That's what buffering is. So what buffering does is, when you're writing this content, instead of writing one character at a time from the program to the hard drive, it will write bunch of characters. Okay, something like this. It will write bunch of characters. The first character that goes from here is this one. Okay, then the next character will be this one. So now the number of trips you make between this program and the next location is less compared to one character at a time. That's what buffering is. The net output is still the same, but the performance varies tremendously. Your performance will improve huge when it comes to writing in this buffered model versus one character at a time. That's what is happening in these two lines. If you do like this, okay, if you do like this, it will still create a file with this content. Yes, no doubt. But how many trips will you make? Several. To write this string from your program to that hard drive file, it will make several trips. And that's what we call as performance hit. Your performance will drop because you're going and writing one character at a time. Okay, just like relocating from your old house to new house. Instead of carrying one thing at a time, you'll carry bunch of things from location 1 to location 2. Then again, the next trip, you again fill up your entire trunk and then go from location 1 to location 2. That is always efficient. And that's what this program does when you use buffered writer. Okay, so you still need to pass the file writer object. Okay, so we call this as a decorator design pattern. Okay, a decorator design pattern is, you take one feature. The main feature of file writer is writing content to file. This is the main feature of file writer. What is this program decorating this existing feature with? What does a buffer writer do? It decorates with bulk feature. Bulk writing content to file. Okay, so you take an existing feature and you decorate that with a new feature, which is buffer. So writing content to file is one thing, but if you add another, like a car, your car is a means of transporting things from location 1 to location 2. Okay, now you add a new feature on top of that. Rather than carrying one item at a time from old house to new house, you decide to group everything in your trunk as much as you can fit. So when your trunk is full, then you travel from location 1 to location 2. And that's what buffer does. It will fill up its buffer and then it will go from location 1 to location 2. So the basic principle is still same, writing content. But what you did is you decorated with a bulk feature or buffered, bulk or buffered writing content to a file. That's why they call the file IO, the input output program in Java, as a decorator design pattern. Okay, because you take an existing feature and you decorate that with some new feature that will improve your performance. Okay, now let's see reading. reading is almost similar. You can read one character at a time, or you can read buffer. Okay, buffer always improves performance, so we are using buffer. So do you see resemblance to the class name and the whole initialization process? File reader takes a file object. File writer takes a file object. You have buffered writer here, and what do you have here? Buffered reader. Okay, so both are still the same thing. Okay, now here, using the buffered reader object, instead of reading one character at a time, we are reading the entire line. Okay, instead of reading one character at a time, we are reading the entire line from the text file. Okay, now here the buffered reader object has a method called readLine. So what is the return type of readLine? What does the return readLine method return?
A string.
A string. We are handling the output from this method in a string. So of course, readLine method will return string. Okay. So the way you read this is, read the first line by calling the method readLine. Okay. Now, if the line is not equal to null, you keep doing the same thing again, readLine. Again, line is not equal to null, readLine. Line is not equal to null, readLine. When will the readLine method return you null? When there are no more lines available in your text file. Okay, so if you have 3 lines here, okay, you have 4 lines. So what does this program do? Let's see. In this, right hand side is processed first. When I say I want to read line, the first line is what you get, writing data more efficiently. Now where is this information stored? When you call this method, the first line goes to which variable?
Line.
Goes to line. So is line not equal to null?
Yes.
Yes, because it has this string value. So when you enter the loop, because it is not equal to null, you enter the while loop, you print that line. So the first line gets printed. Okay. Then on the same line variable, I again invoke readLine method. This time, what do you get in the line variable?
Hi.
You get high. Okay. So now you go back to the while loop and you check, is line not equal to null? Is that true?
Yes.
Yes, because line has the value high. So you enter and you print high. Again, you say read line. What do you get in the line variable this time?
Hello.
Hello. So you check, is line not equal to null?
Yes.
Yes, because line has the value hello. So you enter and you print hello. This time, what will you have in line variable?
Bye.
Bye. Line is not equal to null because line has bye. You print the letter bye, and then you say read line one more time, and what will you have here?
No, none.
This time you have null because there are no more lines to read. When you reach the end of the file, there are no more lines to read. So this time the line variable will have the value null. So when you go back to the condition check, this condition will
Fail.
fail because line is equal to null. But here we are checking not equal to null. That's when you exit the while loop and you close the file handler. That's what this line is doing. Okay, so this is our file content. This time we are going to read this file from our hard drive and going to print on our Java program output. Okay, we are going to print everything here. Writing data more efficiently. Hi, hello, bye. You add anything you want. And your program is reading that. Your program is reading all that content. Okay, all the line by line you get till the end. Okay, so this is one of the use of while loop. The only time your condition will fail is when the line variable gives you null. And that happens when there is nothing to read anymore. If there is nothing to read anymore, that's when you get null. All right. So this is how you read and write text files. Okay, this is how you read and write text files. Now, you guys have been using input output even before this. Can you guys recall where? The very first class of our Java program, our Java session, you guys actually used input output. The very first class. What did you do in the very first class? You created a program, and what did you write inside the main method? Sys out. What does system.out does? Aren't you sending information, writing information to the console?
Yes.
Isn't your program printing this information or writing information on this destination console?
Yes.
That's input output as well. Okay, so we call this system.out as standard input, standard output. Okay, it is standard input and standard output. Okay, the reason we call them as standard input output is these are the standard tools that you have in a system. When you're typing, you type where? On the keyboard. So isn't keyboard a standard input for a laptop?
Yes.
Now when you want to see something, where do you see?
Screen.
On the
Monitor.
screen. So aren't we, when we do sys out, aren't we printing on the screen?
Yes.
So there you go. Sys out is actually a standard output stream, standard output stream. And when you take input from the keyboard, it is called standard input stream. Okay, when you take input from keyboard, it is a standard input stream. When you print something on the console, on the screen, it is standard output stream. So you have been doing input output from quite some time now. Okay, sys out is actually an example of output stream. All right, so let's look at the binary. Now, if character stream is all about alphabets, characters, text, what is a binary stream all about?
0 and 1.
0 and 1. So 0 and 1, what do we call that as? What is the unit?
Binary.
No.
Bit.
What do you remember the first day when we thought about the whole memory allocation and memory size unit and all? What is 1 and 0 called?
Bit memory, something like
Bits. They are bits. And what is 8-bit equal to?
byte.
Byte. So if you notice, when I read, I'm passing a buffer variable. What is the data type of buffer?
Byte.
Be specific, byte array. It is byte array. And what is a string? In case of character stream, we usually read and write string. Okay, we read and write string. So what is a string in the first place?
Array of character.
Yes, it's an array of character. In fact, it's a group of characters, isn't it? Character is one character. String is made of group of characters, isn't it? So when you deal with character stream, you are reading or writing a string, which is basically a character array. Okay, look at the code here. Okay, when we read it as a string. This is nothing but what? Isn't it character array? When you're writing, you write as a string. Isn't this group of character array? Yes?
Yes.
So with that reference, when you're dealing with binary stream, you read and write what? Which array? Character array for character stream. What is a data type in Java that allows you to store these bits? Okay, let's not play the guess game. It's a byte array. Okay, byte is a format for representing binary information, ones and zeros. Byte is what represents ones and zeros. Okay, so if character stream does read and write string, which happens to be a character array, binary stream does read and write byte array. Okay, now the code will be exactly similar if you really notice. Now this is how you write in a character string. Okay, this is how you write in a character string. Okay, now let's see how do you write binary string. Okay, this is character string. This is how you write character string. It reads and writes string. So basically we are writing string. So for binary stream, let's see how the code will look like. It will be almost similar to this thing, with the exception that instead of passing string, what do you pass? In the binary stream, instead of passing string, what do you pass?
Byte.
Byte array. String is equal to character array. We cannot pass character array, we'll pass byte array instead. Okay, so this is how your code will look like. Okay, so look carefully. Here you declare a class which deals with character string, file writer. Here you declare a class which deals with binary string, file output string. Okay, to read a file which is characters, and to read a file which is to write a file which is characters, and to write a file which is binary. Okay, so that's the only difference. Other than that, isn't everything same?
Yes.
You write a byte array, and here you write a character array, string. Okay, if you want to really go line by line, this is what you can do. Exactly similar. Content is character array, that is string, and here the content is byte array, binary. Everything is same. You say write, you pass a string here. You say write, and you pass a byte array here. Okay. In the end, you flush, you close. You flush, and you close. Everything is similar when it comes to character stream and binary stream. Only difference is you have to choose the right class. Okay. If you are dealing with character stream, you have to use the class that ends with a writer or a reader. Okay. If you are dealing with binary streams, you have to end with output stream or input stream. Okay, that's the only difference. Okay, you choose. There are so many other programs for writer. Okay, so you have buffered output stream, you have pipelined output stream. Okay, there are so many other programs. These are all for binary purpose. You see, all these programs that ends with the name output stream or input stream, they are basically dealing with binary classes. Okay, binary streaming. Any program that ends with the name reader or writer, they are for character streams. Okay, just for your own understanding, you'll know the difference. The only thing you can literally read or write is the characters. You cannot really read or write binary. Okay, so that would be a easy way to remember. Okay, even here you have several other classes. Okay, just like we have file reader, file writer. Okay, buffered reader, file reader. You have several readers as well here. Okay, so we have print writer. Okay, so you see here, there are several other streams. Now, the first one, tell me, is it a write or read, and is it a character or binary?
It's a
First one,
binary.
binary.
It's binary. And what is the action? Is it write or read?
Read.
Right.
Right.
Writing. Output is writing. Second one,
It's right.
character or binary?
Character.
Character right.
The character. And the name itself says it's a write operation. Third one,
Binary.
Binary.
binary, because it ends with a stream. The name ends with a stream, so it is binary. Okay. Any name that ends with a stream, they are binary. Any name that ends with a reader or writer, they are character stream. Okay. So how about this one?
Character.
Reader.
Character stream, and of course the operation is for reading files. This one,
Binary. Read.
it's a binary stream for reading
Right.
operation,
Reading.
and so on. Okay, so there are so many customization you can do. Okay, these are so many classes that can help you read and write characters and binary files in as many ways as you want. Okay, you can use any of these file classes. Okay, but you have to choose the right one. Okay, based on what is the file that you want to play with. Is it a text file or is it a binary file? Okay, and when you write the code, it would be almost similar. Here you deal with string. You either read a string or write a string. Here you deal with everything with byte arrays. Okay, if this is a string which is character array, in binary you deal with byte array. Okay, byte is nothing but ones and zeros, binary. Okay, byte array versus string, that is a content type. The class name usually are reader or writer in character stream, and input stream or output stream for binary strings. Okay, it's as simple as that. Okay, now coming to one last thing, what is this flush?
Clearing the memory.
Okay, so typically this is what happens. Now here we have created a buffer of 1 million bytes. Okay, this is a byte array of 1 million bytes. Okay, now this is what happens when you're downloading something from YouTube. Okay, so when you're downloading something from YouTube, you're watching a video. Let's assume the video file size is 5.6 MB. This is the file size. Okay, and you're reading this with the use of buffered output stream. Okay, you're using buffered output stream. You're using this code, buffered output stream. Now the buffered output stream takes a byte array of size 1 MB. Okay, so what does that mean is, if it is 5.6 MB, how many byte is it? Okay, if the file size is 5.6 MB, what is M means?
Mega, so 1024 times 5.6.
So roughly about a million. Okay, more than million, but roughly million. Okay, so in terms of bytes, it is equal to 5.6 million bytes. Okay, that's what this is. Now, if you write a program and you want to download 1 byte at a time, how many trips you have to make between the YouTube machine and your machine?
5.6 million.
5.6 million trips you need to make. Go to YouTube, download 1 byte. Go to YouTube, download 1 byte. So you'll be downloading at a pace of 1 byte for every trip. That will cost you 5.6 million total trips. Okay, so by using the buffered output stream, let's say we are going to read one chunk of 1 million byte at once. Okay, so here our program will not start using the data until it has downloaded 1 MB. Until you get 1 MB data from YouTube, your program will not even care. You'll just go idle and do your own job. You'll just sit idle. Okay, you won't really take any action until a whole 1 MB data is downloaded. Okay, that's the usual understanding of a buffer. Now, you download 1 MB, your program starts reading it. You download the second MB, your program starts using it. Third MB, use it. 4 MB, use it. 5, use it. Now, the last part is 0.6 MB. It is not a complete 1 MB, isn't it?
Yes.
It is 0.6 MB. So will your program read it? Will your program start using it? It won't,
No.
because the buffer is not full yet. Okay, so sorry, this is not input, output, this is input. Okay, YouTube is sending information towards you, so this is input. So what your program will do is it will just ignore the last 0.6 MB, because what program decided is I will only read in chunks of 1 MB to save time. To save time, I will only start reading it whenever a whole 1 MB is buffered. Until then, I won't pay attention towards you. What happens towards the end is your criteria is I will wait until the whole 1 MB is taken in. But the files are not exactly a perfect size, right? They're always like a rough size, 100.2 MB, 5.6 MB, 2.2 MB. So what happens to that fraction data? When the buffer is not full, your program will ignore that. So that's where this method flush comes into picture. Flush is basically if you have reached the end of the file and the last section is less than your buffer size, you want to flush that into your program so you can read the entire file and not ignore the last part. That's what flush means. You guys understand?
Yes.
All right, so every program usually has this flush. In the end, every program you'll see 2 lines, flush and close. Okay, you can use write as many times as you want. You can use read as many times as you want. In the end, you should always end it with a flush and a close. Okay, so flush you're already aware about. Let's see what close is. In case of close, you need to remember this. When you're downloading something, there is like a invisible connection between the YouTube machine and your machine, isn't it? There is like a invisible connection, and on that connection you're basically sending data, receiving data. Okay, now this connection is very, very expensive. This connection requires a lot of CPU power from your machine. Okay, your laptop, your machine has to invest lot of CPU power, lot of resources, lot of memory in utilizing this connection between 2 people. It could be the connection between this program and YouTube machine, or it could be a connection between this program and your hard drive file. Either way, your CPU has to invest lot of resources, lot of power into maintaining this connection. Okay, so as a thumb rule, as soon as you're done, you have to close this connection. You have to close this and you have to close this in order to release whatever your CPU is suffering. Your machine, your CPU is suffering, investing a lot of memory, lot of CPU power. So to reserve that, to save that, as soon as you're done with your program, you have to close it. And that's why every program ends with a close line. Does that make sense?
Yes, sir.
Now, typically, when you write a program like this, there is a chance that you might not end up closing this. When? You might not end up executing this line at all.
When we're using the same file again in different part of the program.
When you're executing Java program, you start from the first line, then second line, then third line, then fourth line. When might you abruptly end up skipping all the lines?
In case of exception,
Yes. Whenever you encounter an exception, you might end up not closing this. Okay, because when an exception happens at this line, what happens? Your program terminates at this line itself. So did you get a chance to go all the way down and close it when error happens in this line?
No.
Did you get that chance?
No.
So this is what we call connection leakage. Connection leakage is when there is an error at certain line before you close the connection. This will lead to a problem. Okay, imagine if you write like 100 files, if your program is writing 100 files, and every time you get an error at the very last line, here you get an error. So when you get an error, all those connections are your CPU, your machine is holding on to that connection forever, even though you're not using it. Even though your program terminated, doesn't mean that connection goes away. That connection is still in use. So that's what we call leakage. This will eventually lead to other problems like your computer is slower. Okay, you might have done that. Try opening like 100 notepad different. Okay, so like this, if I open several files like this, okay, if I open several text files, there is a limit on how many you can open, right? At certain point, your CPU will exhaust. Okay, I'm at 99% and 50, I'm going way too high. Okay, because there are a lot of softwares running here, a lot of files open. Okay, you might have seen this when you're browsing and suddenly your internet is slow or your machine, your laptop is freezing. Okay, it's not, it's slowing down. What do? What is your first reaction? If you have opened several different tabs like this, okay, and you're using everything, Amazon, YouTube, Netflix, what is the first thing you do if your system is slowing down?
We clean the cache, or
you delete all the unused tabs, don't you? Why do you do that?
to save the memory, because memory is allocated to this file.
Exactly. To save, if you're doing multiple things, okay, if you're doing like 100 different things, you might not be able to concentrate on one thing. Your process will slow down. So what do? You ignore the other unimportant 90 tasks and you just focus on the ones which are important. That's the same logic that you use when you're using laptop. If your internet is slowing down, you try to close everything or restart. It's the same concept even in here. If you end up opening too many file connections, it will eventually slow down your machine. Okay, so there is a solution for this. What is it? How do we ensure this line is always executed?
Put
Even
on
if,
finally.
yes. Okay, so what you do is you write try and finally. So this time what will happen is, even if there is an exception in any of these lines, when you're reading, when you're writing, whatever happens, the finally block guarantees that you close this connection. So there won't be leakage anymore. That's how you need to write even file operations. Try, catch, finally, to avoid the connection leakage, file connection leakage. Okay.
This conference will now be recorded.
Okay, I have a student object created. Okay. Now I'll use scanner and use initialize this object. See, this is also an input output, standard input output. Okay, so here is the question: where do Java programs run? Where do Java programs run? Which memory? short term, long term, hard drive, RAM, where does the Java programs run? Can you guys hear me?
All the programs run in RAM.
It runs in RAM. It's a short-term memory. So when you create a student object and initialize with some name, that object is in the RAM memory, temporary, short-term. When the program terminates, what happens to that object?
I think it stays in the memory.
It will be
Or-
lost. It will wipe out clean. Hence the term short-term memory. Okay, whatever you create in that RAM, it will be only used as long as this program is running. When this program terminates, that data will be lost. You can't get that. Is that clear?
Yes.
Yeah.
So serialization, okay? Serialization is a process of taking the object from the short-term RAM memory, Java heap memory, and storing it in a permanent storage, permanent memory. So what's the permanent memory in your laptop?
I drive.
Hard drive.
Hard drive. So here, I'll show you an example now. When you create a student object, I will accept a name from the keyboard and I will store that student's name in the student object, s.name. Okay, I will print it. After the program terminates, if you run the program again, will you have access to that object? Let's see. Okay, enter student name. I'll say John, and it shows me that the student object has John as the name. Okay, now the program already terminated. Okay, if I run the program again, will it be able to print the name John?
No.
No. Okay, let's see. It says null. Student name is null. It already forgot what I gave. Let's try again. I'll give Jane. Okay, before I set the name, I'm printing the student object. Okay, the student object I'm printing, so it will say null. As soon as you create the object, everything will have default value. So the name is default string null. I enter the student name, and this name Jane will now be assigned to the student object. Okay, so at the end of the program, when I reprint, it is showing me the name Jane. So at this line, student object had the value Jane for the name variable. So when I run it again, will it print Jane 0? Because the last time when the program exited, it had Jane 0. So if I print, the first line will be null 0 or Jane 0?
Null 0.
It will be null 0. Again, it already forgot. I gave the value Jane for the student's name. That's what is the problem with the Java objects. Whenever you create a Java object in the memory, as soon as the program terminates, that student object will be lost forever. You cannot retrieve that. Now, imagine this. You're running a website, someone places an order. Okay, you're running the Amazon website, and today 50 million people placed orders. And tonight something goes wrong, your power plug, your electricity shortage, whatever happens, and your system restarts, your laptop restarts. What will happen to those 1 million, 50 million orders you took, which were stored in the Java objects?
They will be lost.
Everything will be lost. Everything. So serialization is very useful in that term. You can actually store all the information that you collect in the Java object permanently somewhere on the hard drive. That's what serialization means. take the temporary Java objects from the memory and store it permanently on the hard drive. Persistent storage. That's what serialization is. Okay. So if that is serialization, what is deserialization?
To delete the stored information.
You take the information from Java object and store it in the hard drive. Deserialization is the opposite, which is you take the information from your hard drive and you load it back in the where did you take it from?
The memory.
In the Java objects. From Java object, okay, which is in temporary memory, to hard drive, which is permanent memory. Deserialization does what?
From hard drive to Java object temporary memory.
Okay, it is from to, that's all. Let's see how we can do that. Okay, so if my program wants to write Java object to the hard drive, what do I need? Input, output, character, binary.
Output.
I need an output because my program is writing on the hard drive location. I need a output. Okay. The second is, our Java program, Java objects, binary or text?
Binary.
They are binary. Okay, Java objects are binary because they reside in the memory. So you need something like a binary string which can write. So basically what you need is an output string. Okay, so let's write it somewhere. File output string. Pass the F object. Here there is another stream called object output string. Okay, it basically reads and writes objects. Writes what? Student object. And finally, close it. Okay, so let's write it somewhere. Okay, student object dot file, whatever. Okay, so same format, isn't it? You declare file object, output stream, object output stream, right? See, is this any different than what we learned in character stream or binary stream?
No.
Exactly same. Compare here with our notepad. Okay, we have a character stream, we have a binary stream. Here we are working on object stream. Okay, it's basically meant for reading and writing objects. Just have a closer look. File output stream, file output stream. Here we are using buffer, but here we are using object because we want to deal with objects. Here you are writing byte array. Here we are writing S. And what was S really?
The object.
The student object. Okay, it's exactly similar to whatever we did for character stream or the binary stream or even the object stream. It's the same concept. Okay, file output stream, then use buffer or object. Here you write buffer, which is byte array, deals with binary stream. Here we write object because this one is meant for writing and reading objects. Finally, you close it. No different. Okay, so let's see. Okay, so the same rule. I'll create a student object. It will print null and 0. Then I take a new name, and here our understanding is whatever name I take here, I want to store it permanently, and I can use it anytime, read it anytime. Okay, so after using that student object, we will write it permanently, serialize that. Okay, right, so it is null and 0. Michael, enter. Okay, now we created this file in D drive. File name is student object.file. In the D drive, student object.file. Okay, so we permanently stored it in our hard drive. Okay, persistent storage. Now let's try to read it. Again, same concept. Okay, create file. This time we are reading or writing. Our program will get data from or to.
Data from.
Data from hard drive. So we are going to read this file. From this file, we are going to read it into our program. Okay, so that is more like an input. So here file output, object output, what is what we used, right? This time we'll use input output, input and object input. Okay, so let me keep that code as well for comparison. Okay, so this is what we did for writing. Okay, we created file object, output stream, object output stream, decorate that with object output stream, write, close. How does the input looks like? File. Here we were writing to the hard drive, so output stream. Here we are reading from the hard drive, input stream. Here the basic read and write operation, we decorated that with object read and write. That was object output. Here the basic read and write operation, we decorated that with object read operation. Here we say write object and pass the object. here when we say read object, what did we get return type? Here you write the student object. Here when you say read, what did you get back?
The stored object.
The student object. Okay, and finally everything closes, and then I'm going to print S. Okay, now at any point you will notice, do you remember what name we gave for the student?
John.
What did we give?
Michael.
We gave Michael. Okay, now this time I won't enter Michael or anything. It will just read it from the file. Okay, it will read from the file, extract the object and print it. Okay, it will just read from the file and print it. Okay, student object dot file D drive, student object dot file. Okay, did you get back Michael from the hard drive?
Yes.
So this student object that we are printing here, it came from the persistent storage. This is what we call deserialization. Okay, serialization is a process where our temporary short-lived object, these are short-lived information. All the objects in the program, they only live as long as your program is running. When your program terminates, when your program ends, all that information will be lost. It's a temporary memory, RAM, heap space. So serialization allows you to store that information as long as you want, permanently on the hard drive. I can run this program 10 days later and I can still get this Michael object intact without any problem. My system can restart. My entire software can be shut down. But anytime I can go to this location and reload this Java object from the persistent storage. Because just because your system restarts, does your hard drive goes off too? No, you will still have all the files in your hard drive. So this is now permanently stored here. Okay, serialization is from the temporary memory, that is your heap space. The Java object can be permanently stored on a hard drive. Serialization. Deserialization is you can take this file from the hard drive and load it back in the Java object, the reverse order. Okay, serialization, deserialization. Okay, now one final thing you need to remember is if you want to store any objects permanently using serialization, or if you want to deserialize, that program has to implement serializable. Okay, you have to note, you have to make a special note on this program saying this program implements serializable. But here is the thing, when you say implements interface, what do you do? When you say implement interface, what is the first thing you have to do?
See if all the methods are there in them.
You have to write the code for all the methods in that interface, isn't it? Here is the thing, in case of serializable, there are no methods you need to write. Just for namesake, you need to write this one line, implements. There are no methods that you need to implement. That's a good part. Do you see any method in this interface?
No.
No. You don't have to implement anything. So that's a good part. Okay, it's an empty interface. It's an empty interface. Just for telling Java program, Java runtime environment that this program is special, you need to treat them differently. This program might get saved permanently on the hard drive. So just to make a note, you have to write implement serializer. But the good thing is you don't have to implement anything because this interface has no methods. Okay.